go.
Are you going to have a special feature today?
Nope. Oh. Not today. Maybe Monday. Here we go. Simplify the following complex fractions. Our goal today is to be able to simplify complex fractions. We already did other rational expressions yesterday. Today we will look at something like this. And in this situation, we have three fractions. See if you can see all three fractions. I have fraction number 1. I have fraction number 2. And I have fraction number 3. A complex fraction is when you have a fraction within a fraction. We do not allow it to be expressed like that. It's the language of mathematics. So if you ever have a fraction, we say it is incorrect. We must resolve it. So the steps are always the same. We first take this fraction and we decide to make one fraction in the numerator. Who can tell me what the common denominator is for the numerator? A. Everybody agreed? So in order to combine the top into one fraction, I multiply the top and bottom by A. What is now this top line going to be right here? 1 minus AB. Yep. Or BA. 1 minus AB. I'll put the A first. What's the denominator? A. Now we move to this part. What's going to be the common denominator here? So I must multiply the top and bottom by B. What do I get here? 1 minus AB divided by B. So what we've done so far is we've created one fraction in the top, one fraction in the bottom. And that's good enough for us to be able to move to the next step, which is very simple. It's what we did yesterday. If you have a fraction divided by a fraction, what do? Multiply by the reciprocal. Piece of cake upside down. 1 minus AB over A times B over 1 minus AB. One minus AB cancels. I get B divided by A. So can everybody see that when you start with this, it's much better to end with that? This is the simplified result. We do not allow complex fractions. So flip it over. Let's write out the steps. What's the first thing you do? Yep, make one fraction the top and top and bottom. Often involves a common denominator. It's the same steps every single time. We start by making one fraction at the top and the bottom. What did you do after that? Multiply by reciprocal. And then finally, after you multiply by the reciprocal, you simplify the remaining expression. Those three steps every time. So, what is the name of this class? Pre-calculus, yep. So the emphasis is on pre and calculus. This is the class you need in order to take calculus. That's the idea. And if you cannot simplify complex fractions, you can't take calculus. It's as simple as that. Just, you can't sign up, you can't take it. Now, to help you understand the importance, for example, if you were in algebra and you didn't know how to solve 2x plus 3 equals 11, you would say you'd have a tough run at algebra, wouldn't you? That's going to be a long year, folks, right? Okay? Same thing with calculus. There's certain things we have to be able to do and have to be able to do well, and one is be able to deal with complex fractions. Has to be able to figure out. So, there we are. Let's try this one right here. I'm going to write it out. 1 over x minus 1 over c. That way I have a little bit more room. Divided by, and now watch this kind of subtle move I'm going to make here. What is the denominator of x? What's the denominator of c? So would you agree it's x minus c all over 1? Okay, good. So the first rule is make one fraction at the top, one fraction at the bottom. I've got one fraction at the bottom. The bottom is good to go. How about the top? What's going to be the denominator for the top? X times c. So therefore I multiply top and bottom by c. And here I multiply top and bottom by x. So, what do I have now? C minus x all over xc or cx divided by x minus c over 1. I now have one fraction over one fraction. What's the next step? Multiplied by the reciprocal, c minus x over cx times 1 over x minus c. Can I cross off the c minus x and the x minus c? I can't. What could I do to make them look the same? Factor out a negative 1. So if I take the c minus x, if I factor out a negative 1, okay, the negative x is going to turn into a positive x. And the positive c is going to turn into a negative c. That's all over cx times 1 over x minus c. Can I now cancel them? Yes. And your result is negative 1 over cx. Where I see some of the mistakes happening, people try to write in a small confined space and you don't understand some of your handwriting. You have to allow yourself to broaden the scope of the problem and to write larger. You have to also be willing to say that this problem is not going to be done over the course of 30 seconds. We're going to do problem number 4 together. You're going to do number 3 on your own. Problem 4 can't be done in 25 seconds. You got to set aside a good 4 minutes to work it through. Let's try it out. This one is taken, this one's taken straight from a calculus problem. Something to prepare you for your next math course. I'm going to write it out a little bit larger. A plus h over a plus h plus 4 minus a over a plus 4. All over my h. Okay. What am I going to do here to create a common denominator? Add an h to the top and bottom. Multiply top and bottom by a plus 4. So see an a plus 4 here and an a plus h plus 4. You're going to have to multiply this side by a plus 4. What do you have to multiply the other side by? This is one of those times people are like, well, I must be making a mistake because that looks like it's a lot of work and math problems are only supposed to be 45 seconds at most. Nope, sorry. Let's trust the process. This problem is going to work out beautifully. What is a plus 4 times a plus h? A squared plus 4a plus 4h. What else? A times h is ah. Probably the first time you've ever written that, right? I got one laugh. Should I distribute a positive A or a negative A? What do you want to do? Can we distribute a negative? Negative A times A is going to give me negative A squared. Then what? Negative AH, and then negative 4A. So that's our top numerator. That's pretty large, isn't it? The bottom, don't multiply it out. Just leave it as A plus 4 times A plus H plus 4. You can. Some people just use their hand. What do you notice? Yeah, if you combine like terms, A squared and negative A squared, they're gone. What else goes away? AH and AH, 4A and negative 4A. What are you left with in the numerator? Just 4H. So if I write it as 4H over A plus 4 times A plus H plus 4, and then instead of dividing by H over 1, we multiply by 1 over H. What happens? H is canceled. And now you're done. 4 over A plus 4 times A plus H plus 4. A little tricky, huh? I did the tougher one. Try number 3 on your own. Take a good 5 minutes, okay? See if you can work it out on your own. I'm going to come around and help give you pointers as you start through. Yeah.
Could it have also turned into just positive x plus c? Like, could you factor out negative 1 for both of these and then cancel them out that way?
So I think I see what you're saying. But if you were to factor out it for both of them, then if you factor a negative 1 out there, then what happens is the c turns positive, but then the x turns negative.
Oh, okay.
So it does work out that if you were to factor out the bottom, then it would have canceled with that.
Okay.
Doesn't matter if the negative is in the top or the bottom. So just to be clear, a negative 1 over cx, that's the same as 1 over negative cx, which is the same as negative 1 over cx. So it doesn't matter where the negative goes so long as there's one of them. Okay. Yes. So if I factor out negative 1 here, then the negative x turns to positive and the c turns to negative. Yep.
So I can't subside by 1 plus h.
3 plus h.
Or that h also like
So we're going to do 3 over 3 times 1 over 3 plus h minus 1 over 3, and then it's 3 plus h times over 3 plus h. That creates a common denominator, 3 times 3 plus h. That's what the common denominator should be.
Can I ask how we got there?
So, for example, suppose that, like this expression here, you see it as 3 plus h. Suppose it was a 7. And then on the other side, you had your 1 over 3. You see how you have to multiply top and bottom by 7?
Yeah.
So in here, you have to multiply top and bottom by 3 plus h.
Yeah.
And here you have to multiply top and bottom by 3.
Oh, I see what you're saying. I did that. Okay, so this should be a 3 plus h, not,
Yes.
not 1 plus h. Okay.
Is this okay if I, like, is this how I'm supposed to do it?
Yes.
Okay, perfect.
Now, see what you get in the top.
Alright, I have a question.
Yes, but you must distribute your subtraction sign. That's a negative h. No, that's fine. But when you distribute, look, you have a negative h there. So it should be a negative on top.
So you come up so that.
So you see how your h is negative? So you got your negative just disappeared.
Do I have this part set up right?
Good. So 3 minus 3 is 0, right?
Yeah.
So you get a negative h. Your bottom is, I'll just write as 3 times 3 plus h, okay, times 1 over h. So now the h's cancel, and you get negative 1 over that. So you had a lot of it set up correctly, but you want to see that first. Yep. Yep.
Okay, so ignore my negative 1. Okay. So. Okay, so I did that, right? So I got, and then I also decided to distribute this negative part was added. So then I got 3 minus 3 minus 8.
Yep, and so the 3 minus 3 goes away.
Yep, so I got negative 8.
Good.
Over, so then I transformed into this.
Yep.
Can I cancel this side away, or do
Yep.
I need to make
Yes.
this
Nope, that's fine. So you get a negative 1 over the 3 times 3 plus h.
So, okay, so since that's minus and you multiply by 3 plus h,
Yes.
the whole thing turns negative?
The negative, yep, the h turns negative as well, and then those will cancel. Negative 1 on the top. You can cancel out the h's, but the negative remains. A negative 1 in the top.
Negative 1 over 3 times.
Yes. Yep.
Oh, so I was just extra.
Yep. Okay, let's check it out. Sorry, YouTube. I had my mic on that whole time. Normally I pause the video, but I forgot. So yeah. Anyway. Okay, so I like what I saw from most people here. People saw that you multiply top and bottom by what? 3. Top and bottom by 3 plus h. Okay? All right? So we have a 3, and we have a minus 3, and we have a minus h. A lot of times people forget to distribute that negative all the way over. I choose to not multiply out the denominator. I choose to leave as 3 times 3 plus h. I like to leave that denominator in factored form. If you wrote 9 plus 3h, that's fine as well. Okay? So what cancels? 3's are gone. Okay? And I multiply by 1 over h, and you notice what's going to cancel there. The h, so you're left with a negative 1 in the numerator and a 3 times 3 plus h in the denominator. You all good? Okay. 2 more. These actually work out pretty well. I think number 4 for a lot of people is the most challenging one. So what's going to be the common denominator for the top? Okay. And what's going to be the common denominator for the bottom? So x plus 2's top and bottom. We all good? Okay, let's multiply it out. X plus 2 times x minus 5. This should be a minus 3x, then a minus 10, and then it looks like I have to pick up the minus 18 over there, right? Okay. Over, what's the denominator? Over x squared plus 9x 14 plus 6 over x plus 2. Sweet. Now I have a fraction over a fraction, so what do? Multiply by the reciprocal. So I'll multiply by x plus 2 on the top, and x squared plus 9x. Isn't that just going to be a plus 20? Plus 20. So usually I do that. I then cross out to show that I'm doing that. That's how I like to show my work. What happens now? The x plus 2's cancel. And then this minus 10 minus 18, is that just a minus 28? So is it possible that the top and bottom factor to where something might cancel? It is. So let's just check. What does this top factor to? X minus 7, x plus 4. And the bottom factors to x plus 4, x plus 5. So it looks like the x plus 4's do cancel, and I'm left with x minus 7 over x plus 5. We good? Okay. Last example. Can I erase this? Okay. So the last example, super important just for your general understanding about how exponents work. If I had a y times x to the negative 2, that would be the same thing as y over x squared. Agreed? Yes, that is true. But if I had, say, x plus y to the negative 1 over, say, y squared, you can't just take this y and drop it down there. You have the addition sign, so these are kind of tied together. Okay. In fact, what you would have to do is write as x plus 1 over y, and that is over y squared. Do you see the difference between just dropping the y down and writing as 1 over y in that scenario? So you can tell that when people see this expression in number 6, they might like to just move these up and move those down right away, but that doesn't quite work. In fact, when you have the addition and the subtraction in there, the way we write this is 4 minus 4 over x plus 1 over x squared. I want you to look at that and convince yourself that that is the equivalent expression to what we see as it's first written out in the numerator. Okay, can you see that those are the same? We all good with that? Okay, so then what would the bottom read then? Yeah, 4 minus 1 over x squared. Good. So now we've written in a way that we can now finally work towards that complex fraction simplifying process. So what's going to be the common denominator in the top? X squared. So I should multiply top and bottom by x here and by x squared there. So what's that top numerator going to look like now? Good. 4x squared minus 4x plus 1. And my new denominator is x squared divided by good. So you already saw that you're going to multiply top and bottom by x squared there. And so now we have that common denominator. So you got 4x squared minus 1 over x squared. Yes, sir.
So the next step, instead of like multiplying it by reciprocal, could we factor it out this that thing?
Yeah, if you want to factor it and then multiply by reciprocal, that's fine. For the sake of this class right now, I am going to just multiply by the reciprocal, and then I'll factor after that. So we now have a fraction over a fraction. You recognize that the step now is to multiply by x squared over 4x squared minus 1. What happens? X squareds cancel. Kenny led us to believe that the top and the bottom might factor. Do they factor? Yeah, they sure do. In fact, the 4x squared minus 1 is simply the difference of two squares, isn't it? And then the top, I think that would factor to 2x minus 1 and 2x minus 1. Is that accurate? So it looks like now the 2x minus 1s will cancel, leaving us with a grand total of 2x minus 1 over 2x plus 1. a little bit challenging problem there. Please take out your homework packet. There are 16 problems. You don't have to do all of them. I'd like to point out the ones that you need to do, and then the ones that you may choose to do. So I have Izzy's homework packet here, problems 1, 2, 3, and 4. Those are all excellent problems to work through. So you can see I've tried to give you plenty of space. Problems 5, 6, 7, and 8. Those are, again, excellent problems to try. From 9 through 16, choose 4 out of the 16. Some people ask which ones would be best to try. If I were to try ones, I would try 10, 12, 13, and 14. But you do what you want. And I want to be clear, it's okay to be a person who identifies and says, I would like to do all 16 because it's my favorite class and I love to do math. Anybody ever have a time where they're done with their homework in a class and they take out a book and start reading? Okay, right here. What book are you reading right now? Okay. And does anybody ever judge you for that? Oh my gosh, can't believe you're reading. A few people do. I didn't do the reading thing. What I did is I would first, when I got to math class, I would find the book and I'd try to find the 4, 5 hardest problems in the book that I could. And I keep those on a piece of paper in my back pocket. And when it was time for people to then read in class, I would take out problems, I'd start working. So have you judged me now? Izzy, are you judging me? Yes, she has. So it's okay to begin to embrace whatever level of nerdiness you may have. The world wants nerds, don't they? Yeah. You want the doctor to treat you someday who got the job simply because they wanted to make a lot of money? Or do you want the doctor to be working on your knee someday because they really think that cutting apart kneecaps and putting them back together is really cool? You want the nerdy one, right? You do. So embrace your work, folks. It's okay. You have the rest of the hour to work. I'll come around to help. Tomorrow is a complete work day.